Oops. So I just swiped through this. Okay. Right. Where is it now? Okay, here it is. All right. So again, this is another problem to demonstrate the fact that this time we don't have any lateral load, but we have the unsymmetrical frame and unsymmetrical loading condition. So this frame is going to sway. So if you begin by, identifying the behavior of this frame incorrectly, and by saying identifying the behavior incorrectly means that you identify your unknowns incorrectly. So you're doomed from the beginning. Okay. So let's give it a proper name. Okay. Let's call this A, B, C, D, E, and F. Okay. Now we have support D, E, and F as a fixed support, so there's no rotation there. So if I may write down, oops, here I go again. Okay, if I write down my unknowns here, you have a rotation at A, at B, and at C, and then you are going to have the frame that sways. Oh, excuse me again. The frame that sways. Let's assume that it sways to the right. It doesn't matter which direction you assume. In the end, you see it by the numbers. Okay. So let's say it's gonna go to the side like that. But again, we have one floor, and we assume the axial deformation is negligible. So this delta here must be equal to that delta. That must be equal to that delta. So the delta, so they are equal, but it creates the unequal psi angle, because you see in this case the lengths of the columns are different. So okay, let's get going. So the unknowns here. Step number 0, we identify that our structure has 4 unknowns. And we have zeta A, zeta B, zeta C, and then delta. Okay? And I can just perhaps proper to do it now, that psi AD, okay, is equal to delta over the length of member AD, that is 3. In the meantime, psi BE is equal to delta over 4, and psi CF is delta over 5. Okay, if you don't do this step, you will end up with more unknowns that you can establish your equilibrium equations. Okay, and step number 1, that is the relative stiffness. Okay, this time we have so many members. We have 5 members in total. KAD, that's I over 3. KBE, that's I over 4. KCF, that's 1.5 I over 5. And KAB, it's 2I over 4. And likewise, KBC is also 2I over 4. So I used K equal to I over 12. My least common number is 12. So I have KAD as 4K. KBE becomes 3K. KCF becomes 3.6K. You may argue that you can use a better number, I agree. And this becomes a 6K and 6K. All right. Remember that even though this is a sway problem, but it sways because of an unsymmetrical loading condition, and therefore we have the fixed moment. Okay, we have FEM AB. It's a point load in the middle, so you would use PL over 8. And it's minus because it's on the left, it's counterclockwise. This is minus 8. L is 4 over 8. So you have fixed moment equal to minus 4 ton meter. And this is equal to minus FEMBA, which is 4 in the end. Okay. So now we move on to the step of writing our slope deflection equations. Okay, it's going to be a lot of equations, you know. So let me begin with MDA first. Okay, I don't know if I should wear the glasses or not. It's high time that I have new glasses. MDA is 2E. It's 4K net. Okay, and then 2 zeta D plus zeta A minus 3 psi is delta over 3. Remember, psi AD is here and KAD is that one. So that's your equation. And zeta D is 0. Let's come back and take care of zeta, 0 zeta later, okay? MAD is up next. 2E 4K 2 zeta A plus zeta D minus, notice that the psi term is always the same in one member, okay? Next, let's move on to the middle column. MEB, that's a 2E, what's the K for that one? I think it's 3, right? 3K 2 zeta E plus zeta B minus 3 psi is delta over 4. And then MBE, that's 2E 3K 2 zeta B plus zeta E minus 3 psi, which is again the same term. And the last column, MFC, 2E, that's 3.61, right? 3.6K, 2 zeta F plus zeta C. Excuse me if it looks a bit like you have a minus sign there. 2 zeta F plus zeta C minus 3 psi, which is delta over 5 this time. Then MCF, it's 2E 3.6 K to theta C plus theta F minus 3 delta over 5. Okay, so let me pause here and take care of all the theta that become 0. This is 0, 0, E is 0, and F is 0. Okay. Now we move on. Oops. Ah, damn it. Now we move on into the beam portion. And we have MAB. That's 2E 6K 2 theta A plus theta B. Remember your beam, your two beams don't have the joint displacement this time, so no sine term. Minus fixed end moment 4. MBA is 2E 6K 2 theta B plus theta A but plus 4. And MBC 2E 6K 2 theta B plus theta C, no fixed end moment. MCB 2E 6K 2 theta C plus theta B. Okay, so that is your slope deflection equations, like 10 in all, and now you've got to be, very well organized. And step number 4 is equilibrium equations. We have sigma MA equal to 0. Sigma MA was our joint A. So let's go back a little bit. That's joint A, right? There. So it's MAD and MAB. That's your MAD, and that's your MAD is here, and MAB is down here. Okay. So, I think I'm gonna try to go quickly because there's no point trying to do some simple arithmetics for you. Now you know the idea. So let's go over it a little bit quickly. Okay. So I'll just add them up for you. And let me write it down here that it's MAD plus MAB equal to 0. So that gives me 40 EK theta A plus 12 EK theta B minus 8 EK delta minus 4 equal to 0. Sigma MB equal to 0. This time you're going to have MBA plus MBC plus MBE equal to 0. So that gives you 12 EK theta A. Notice that, ladies and gentlemen. That's 12, that's 12. So, you should feel good, right? Plus 60 ek zeta b plus 12 ek zeta c minus 4.5 ek delta plus 4, sorry, equal to 0. Very long. Sigma mz equal to 0. Now, when you are, when you have done this a lot, you should expect that you're gonna get the same some numbers, right? So here is mcb plus mcd. For example, that's zeta a, zeta b, zeta. You don't have zeta c here, so you're not gonna have zeta a in the first column. So that the coefficients are the same. So right, we don't have zeta a in sigma mz, right? So we begin with let's say 12 ek zeta b, and again you see, that is zeta c term is ek zeta c term is 0, so you have ek zeta a term here 0 as well, so they're the same here, and then that's 12, that's 12, so you should feel good. Plus 38.4 ek zeta c minus 4.32 ek delta equal to 0. Okay, and here comes the big one. Okay, that is sigma fx equal to 0, but this time, because our frame doesn't have any horizontal load, that means some of them just gonna go the opposite direction, because in the end it means that hd plus he plus hf will have to be 0. Okay, and you have hd that comes from this free body diagram, right? That and that and that. So hd is equal to mad plus mda over the length 3. And likewise, he, if we use a similar free body diagram, it's mbe plus meb over 4, and hf is mcf plus mfc over 5. And if you notice, this becomes more like repetition of the problems. You don't need say a lot of intelligence doing this. You just need to stay focused, okay, and concentrate. So here AD plus DA, you should know that they have a similar trait, AD and DA. So in the end, this is 24 ek zeta A minus 16 ek delta divided by 3. This is 18 ek zeta B minus 9 ek delta over 4, and this is 21.6 ek zeta C minus 8.64 ek delta over 5. So you add them up, in the end we have 8 ek theta A plus 45 ek theta B plus 4.32 ek theta C minus 9.311 ek delta equal to 0. So you see, we have 8 here. So you would expect that to be 8. You see that? And in this, we have 4.5. So that is also 4.5, I believe. Yeah, I missed the dot. Okay, and there you have 4.32, so it's 4.32. So when you see this, you should, wow, at least we are good to go, right? Huh, I only have 2 pages for this. So I don't have space to write anymore. I don't know why I only had 2 pages. And that's a PDF file, so that means I cannot increase the space. So pardon me, but I need to switch to my node, okay? So let's do that. So from that, okay. This is nothing more, nothing less than, you know, writing numbers down. It's kind of crazy, but let's give you the number anyways. N moments. MdA is equal to only 0.39 ton meter. Oh, you know what? I forgot to give you this, the answer. So let's erase this. Sorry. Let's begin with the answer. Ek theta A is 0.1493. Ek theta B is minus 0.9733. Ek theta C is 0.4174, and Ek delta, that is 0.1006. So from this, we can have our N moments. You just plug this back in to your slope deflection equations, okay? And you have MdA. Oh, I look like dA. Would it be better if I reduce the size of the pen? Oh, like this.
Teacher,
Yes.
can you go to the last page?
Okay. One moment. That one.
Yes, last one.
This is the last one.
ขอถ่ายรูปกันหนึ่ง
Okay. Just speak English. Okay. Okay, so that's it. You done? Hope so, right? Taking a photo should take like 1 second.
โอเคค่ะ
Okay. All right. So here we are. So let me try to write with a smaller line. See if it's better. MdA, it's 0.39 ton meter. That's better. MAD, feel much better, not much. 1.58 ton meter. MEB, it's minus 1.04 ton meter. MBE, it's minus 1.62 ton meter. MFC, minus 0.13 ton meter. Rather small, you see. MCF, .17 ton meter. Let me go over this way. MBC, minus 1.84 ton meter. MCB, minus 0.17 ton meter. MAB, it's a minus 1.58 ton meter. And last one, MBA, is 3.46 ton meter. Again, after all this, you know, our equilibrium should hold. So you see, what do we have here? So many. MAB and MAD should be equal and opposite, right? So AB and AD, you see, equal and opposite. So that sigma MA is 0. CF and CB is next. CF is here, but CB is there, so it's 0 as well. And the last one is the sigma MA. Okay. So let's use the big one. So you have to include BC, BE, and BA. You know, you sum them up. These three should be equal to 0. Okay, so that's it. The next is it's just a completion of the free body diagram to write your shear force and bending moment diagram, and that shouldn't be a problem. Okay, so that's 6. How do I call it? Shear. The first column we have 1.58 and then 0.39. They all go clockwise, so you have the counterclockwise shear. Okay, and that is the summation of two moments divided by the length, and that is 0.66. The next is the beam here with the point load 8 tons. And you have end moment here, 1.58. And there is 3.46. Okay. And that gives us the shear of 3.53. And here is 4.47. The middle column, let me write it somewhere here maybe. So we have the moment in that direction, 1.62 and 1.04. It's all gone counterclockwise, so we have this clockwise couple, 0.67. Next one is this beam. That's 1.84 and 0.17. So we have a rather small force here. Clockwise, only only 0.5 ton. And the last column, um, 0.17. And 0.13 and almost no shear at all. 0.01. You see, because you see that this member and this member almost have no force on them because the load is just right here. Okay, and this is just the moment that is caused by the unsymmetrical nature of the frame. So it go sideways a little bit, but not, you know, in just like, you know, when the frame is being pushed by the lateral load. Okay, I hope that you guys can finish your shear force and bending moment diagrams by yourself. So that's it for today, folks. I believe it or not, we are finished with the slope deflection. How's that? Okay. So I think, is there any question regarding this so that we can stop the record first? Any question?
I asked on the chat because I can't pronounce.
Oh, on the chat. Okay. Delta. It's delta. It's like this is the delta, you know, triangle. Why FEMAB is negative? It's counterclockwise, isn't it? You mean this one? FEMAB is negative, right? Correct one. If you draw, that's AB, it's counterclockwise, so it's negative. Okay? And
So we determine that the
determine.
The counterclockwise.
If you determine the wrong direction, it doesn't matter because it's gonna come out in the end, and you will know from the answer. Remember that we use clockwise positive, so we will stick to that, and you will know in the end whether or not you determine correctly. But maybe this is the, you know, clockwise, right? So I assume clockwise. Psi is clockwise.
I get it.
Mm-hmm. Okay. All right.
And I have another question.
Yeah, go on.
That's in the how to know that the delta is go to the right hand side. So
it is clockwise. You see, you thought you said you understood it. This is go to the right, so my psi is positive. You can assume anything, but you just need to know that, okay, if the delta is to the right, your psi is positive. Perhaps I should do a better job here too, you know, because right here I was too careless. This actually, the psi is negative, so it should be negative here. You know, this should be negative value. That, right? My apologies. Okay, so that's why the psi is swapped. Oops. Okay, sorry. Just gonna need to call him back soon enough. Okay. This should be positive too, you know, because actually what I'm doing here is that I also assume that my my rotation goes this way. Yeah. That's why the side swapped, but I couldn't tell because I didn't know how the calculator that I use identify the simultaneous equation. Okay. So thank you for bringing this up. So what I actually did with this problem was that I assumed that actually the frame moves to the right, and in the end, you know, the answer would tell you that actually it's not. Okay.
Okay.
I'll clear this one up better. Okay. And so you know, but you can have the clear picture of the sign convention, but that's exactly what it is. Okay, with this one. It goes clockwise, so it's positive psi term. Psi is positive. Okay. Good question. Is there anything else?
Teacher, the active class, my friend, I get the watch. My friend want to the active class to online, teacher.
Most of them?
The active
of them?
class. Yes, teacher, I vote in line and I want to ask the my senior.
It's okay. You know what? If it's not about a class, let me stop the record.
Okay. Oh, thanks. Sorry.